you call little dry, okay, but hopefully this you will know, understand what is the connection between the three cycles that we talked about in the AC, okay. Can somebody recap what are the three cycles that we talked about, or shall I start picking up names? Anyone? Which were the three cycles we talked about last time? Hmm? No one? Did you understand whatever I said last time, guys? Yes or no? Somebody can type out, chat, whatever. Because this is a tricky subject. If you don't understand now, it will be very clearly seen in your drawings and diagrams and reflected in your papers. Hello? Which are the three cycles are there in a AC cycle? Kanchi? Are you there, Kanchi?
Yes, I'm here.
Can you tell me at least one cycle that you are aware of in a AC cycle, the whole thing that we talked about?
Just a second. I'm trying to find my book. I don't remember the names actually.
It's okay. You don't need to remember the names. So there are three cycles involved, right, at various levels. Okay, I'll give you one clue. One cycle is within the basement where the refrigerant does the flow, okay? From evaporator to condenser, blah, 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 and everything. So that is happening only at the basement level. Which is the other cycle? Nishanti, are you there?
expansion cycle.
Expansion cycle, yes. So उसमें क्या होता है?
The uh, the coolant is converted to gas and it takes up the heat from the
Okay, so that
atmosphere.
happens in the basement. Perfect. So that's what I said. Okay, so that happens in the basement. अब वो तो हो गया आपका cooling और heating. अब क्या करना है? What is the next step? What are the other three components that will come into the picture? So this is happening at the basement. हमको basement तो cool करना नहीं है. Okay, we have to cool the space at the other levels. So how do we then manage that? So for that, you have another two components added to it, and which induces these other two cycles that I'm talking about. So what are those two other cycles? Which happens continuously, simultaneously. If they don't, the AC will blast.
Compression.
Compression हो गया, वही वो है, वो compression is happening at the basement. Okay.
Uh,
Um,
cooling,
yes, cooling off.
condensing
Yes,
effect.
perfect. Yes, thank you, Ishan. This is cooling of condenser, because if you don't cool your condenser, can you imagine the heat that will be there? वो coil burst होगा, okay? The water will start boiling inside repeatedly and no cooling will happen. वो तो दूसरी बात, लेकिन यहाँ पे it will start bursting out. And which is dangerous because we don't want refrigerant to be exposed to the air. So this is what is going to happen if you don't cool your condenser. अब cool कैसे करें? There are two methods, okay? So condenser का दो method है आपको cool करने के लिए. एक तो बड़ा सा fan लगा दीजिए, which will cool the condenser. But then the resultant would be a huge, humongous amount of hot air. My question would be then, what will I do with that air? Okay, I cannot, as a principle or on a moralistic manner, I cannot dissipate that huge amount of air to the atmosphere, because the building next to me, behind me, in front of me are or will be subjected to this tremendous amount of heat, and it will kind of give a very stark urban heat island effect, which I don't want to happen. Okay? So when I'm talking about sustainability and I'm talking about high rise building, which we already did with your class, and you guys are doing on high rise, okay, where a lot of these systems are involved, we have something called as a heat recovery system. So वन थिंग इज, सपोज मुझे हीट रिकवरी नहीं करना है, आपका ये बिल्डिंग जो है वो एक कॉर्पोरेट बिल्डिंग है, ठीक है, जिसमें कोई हॉट वाटर सिस्टम की जरूरत ही नहीं है, से फॉर दैट, फॉर एग्जांपल, ओके, and if you don't need that, then in that case what you need to do is you put a cooling tower at the top of your terrace and run continuously. तुम्हारा जो नॉर्मल चिल्ड वाटर, चिल्ड नहीं, नॉर्मल वाटर होता है टैप वाटर वाला, ओके, यू डोंट नीड टू चिल दैट. That water is continuously cycled up and down, so that means there is a continuous set of pumps working 24/7 if the building is working 24/7 or shift wise, okay, and that pump will be on and on to push that water up. The water will come down, it will go up, it will come down, and in that process it will transfer the heat from the condenser to the cooling tower. ठीक है, ये तो एक साइकिल हो गया. What is the third cycle? The first cycle was the refrigerant, जिसे हम compression cycle कहते हैं, which is happening within the basement. That is a cycle which involves your refrigerant, which is going within that 4 modules. Okay, 4 modules क्या क्या था? Evaporator, compressor, condenser, expansion valve. So this is the compression cycle. Second one is the condenser cooling cycle. Third one कौन सा साइकिल है? अब आपने हीट तो ले लिया, हीट जितना आपने डिसिपेट किया है, दैट्स व्हाई यू आर गेटिंग चिलिंग, राइट? You need to push this chilling somewhere, because that is the whole idea of air conditioning. So you need to take that coolant, whatever it is, either air or it is water, you need to take that and push it to wherever you need it. Okay, so that is your third cycle. Okay, there also guys, imagine करिए आपको हवा लेके जाना है, okay, you are chilling the air and you need to push that air to say third floor. तो क्या एयर अपने आप जाएगा? Even if it is an air, it won't, right? Because it's cool air has a higher density, it will tend to sit. तो आपको pressurized pumps लगाना पड़ेगा, and you will have to pressurize the ducts to lead the air up. That's another way. So you need a high pressure ducts, नहीं, actually pumps नहीं चाहिए, you need a fan. Or in the other case, you will require chilled water system. अगर है तो आपको वो chilled water, which is the coolant, the degree of that water is around 6 to 8, 10 degrees. Okay, you need to take that chilled water to wherever respective places you need to go. Okay, where it again the heat transfer happens, it gives away all its cooling to the AHU and come back again in a normal form. Okay, फिर से वो ठंडा होता है, फिर से ऊपर जाता है, and that cycle also continuously, simultaneously, 24/7 if the building is working 24/7 continuous. ठीक है, तो ये होता है तुम्हारा 3 cycle. Today we'll be studying, so we are recapping the system diagram. Okay, so let's start. Okay, so this is ये हो गया आपका space. Okay, now this space you can imagine on 16th floor, 15th floor, 10th floor, whichever floor you are having bias towards. Okay, so space, then you have your AHU. Okay, now we are talking about centralized system. Unit system we'll talk later on. Okay, so centralized system ऐसे होता है. So you have space, you have AHU, you have AC plant room, and you have cooling tower. This is how you are going to, these are the 4 main components of your entire AC system. One second, guys. I need to charge my mobile. Okay. Okay, so so you have these 4 spaces. ठीक है, अब ये 4 space में क्या होता है? So you have hot, used, unclean air. I wouldn't use the word unclean, but yeah, not very clean air. Okay, you will send it back to the AHU. What is AHU? Is nothing but air handling unit. My request to you guys, I can't see you, okay, but I trust you, and please write down these words. Okay, so this is nothing but used air to AHU. और AHU क्या करता है? Chilled air to space भेजता है. So this is one transformation of heat. AC, by the way, guys, is nothing but I have to take the heat from the room where I am there or you are there and take that heat somewhere out and dissipate it. We are just seeing the travel of that heat, where the heat transfer happens, so that finally the heat is thrown out. ठीक है, बहुत simple है ये. Okay, there's nothing complicated about it. If you understand the logic behind it, it is very simple. So you have the space. Space is used by us and the machines. It heats up the air. That heated up air will be sent back to the AHU, where the AHU will chill the same air and push it back. We do not replace the complete 100% of the air. बहुत महंगा पड़ जाएगा. फिर AHU क्या करता है? अभी AHU गर्म हो गया ना, इसने अपना हीट लिया, ठीक है, एंड जो नीचे से तुम्हारा चिल्ड वाटर आ रहा था या एयर आ रहा था या whatever, now it gives the chilling away, so it is now given up its chilling, so now it has to chill again. So what it does, वो जो सारा heat उसने collect किया from the used air, now it is pushing on to the AC plant, ठीक है, so it sends the hot water to the AC plant room. और AC plant room क्या करता है, which is at 14 degree, okay, AC plant room क्या करता है, it sends in the chilled water. Okay, now this cycle is completely going on and on. So this is at 8 degree. You can see the difference between the water, 6 degrees. Okay, now AC plant room क्या करता है, AC plant room में कहाँ पे heat convert होता है, condenser. Okay, so now all that room, all that heat from the room is now finally coming and getting converted into heat at which level, at the condenser level. ठीक है, वो सब कहाँ पे होता है, AC plant room में. तो AC plant room क्या करता है, I need to cool the condenser, and so it goes to the cooling tower. So the final dissipation of the heat is then to the atmosphere, but in a very, very gentle manner, unlike the fan cooled condenser, which is very harsh and absolutely not sustainable. Okay? So this is how the entire space or the entire cooling happens. Okay, so it's from this, it's very easy to understand कि AC में कोई magic नहीं है. Okay, जितना आपको chilling चाहिए उतना ही आपको heat मिलता है, and somehow either you are what do you call, sensitive to architecture, sensitive to environment, to ecology. Your job is then finally devise a system or talk to your consultants. You are not in a capacity to devise a system. That's not your job. But you can definitely hire the consultants or advise your clients to say that, okay, you go for these clients because they are far more sustainable advisors, okay, and they deal with the sustainability, they deal with the ecology, and probably they can help you out to recover the heat that we are creating, okay, and probably put it back into the system ताकि हमको ही फायदा हो. Like suppose if I need hot water system in that building, why will I send that hot water to cooling tower? Okay, I will send that hot water to my hot water boiler. So already the hot water is coming to the boiler, so boiler will not have to go and blast its full energy on. वो हल्के से energy में काम करेगा. That's how I save energy. So this is called heat recovery methods. There are other ways also of recoveries. Okay, so the heat can be suppose this heat laden water is then cooled and that condensed water is taken out, so the heat is converted into water. ऐसे भी होता है. So there are lots and lots of method of heat recovery. Okay, I'm just telling you one or two. So this is how the system will perform. AHU क्या होता है, is at each floor level. Okay, it requires heavy duty maintenance. Every day maintenance is required. It requires ventilation, and I will show you why in the next sheet or the next slide. It makes heavy sound. Okay, बहुत आवाज करता है, makes sound and creates vibration. So you need to have acoustical treatment, you need to have vibrators or vibration control system, यानी कि your structure has to be in place. Okay, it needs to have good light. Okay, and definitely access, because I need maintenance. So, and this happens at every floor. So mind you guys, your skill as a spatial planner will come into the picture, because you don't want a large number of people coming back and forth through your working area to pass and go to the maintenance area where you have your AHU. It's kind of disturbing. And we don't want that. So that's how you will core your building, okay, or zone your building, where the entire services will be kept together, and then the working areas will be free of these people. AC plant room, we have done it, okay, but still it also requires, it can be at the basement, it could be at the ground level, and it could also be at the terrace level. But you know what will happen at the terrace level. That means whenever, okay, when the building was done, then only the AC will come. Na pehle to AC लगाएंगे नहीं. आपका building हो चुका, then you will have to take a crane and take that machine and put it on the terrace, okay? Or if not that, then you will have to provide, whether you like it or not, you will have to provide a very large kind of a lift into which this machine will go, and then it will be taken up. Third option. Third option will be from the manufacturer side. They will come, in a all different parts and bits, like how IKEA delivers the subject, I mean the furniture to your home. It will come and it will assemble everything on the terrace. That is the final third option, which nobody opts for. Okay, it's too tedious. वो कोई करता नहीं है. So this is what you will have to do then. Okay. So terrace wala thoda dicey hai, unless it's a VRV system, because VRV system comes in small slots and it can be joined and increased and decreased, whatever it can. That's why it's sustainable. Uh, Cooling tower is definitely at the terrace. The reason I have explained to you last time, it requires a blast of air going over it so that the water that trickles into that jali like thing and collects into the tray before it comes down to the basement, it needs to have this hawa going over it so that it gets chilled, or cooled rather, not chilled. Okay. So it requires maintenance. Okay. Needs open space around it. Also, that open space around it needs to be cleaned every day. If not done so, what happens is, because there is this constant spraying of water, and if the suppose it's a shady part of the area, suppose, okay, then it will turn into something like very mossy and slippery. So वो आपको ध्यान रखना पड़ेगा कि where you keep it and how it is maintained. Okay. And excess definitely, and refilling of tanks. That means because there is sprinkling of water, that means there is a loss of water. And I already give you an example. I don't know whether I told you or the other class that in Burj Khalifa, the makeover water, or the water which is condensation coming from the AC plant room, is around 15,000 million. I mean, some water. Okay. Yeah, 15 million. I am sorry, I don't remember the exact number, but yeah, something million and 15, that much I know. We were 1,000 hai ki nahi, I don't know. That much water, even if I take 15 million liters, is like, oh my god, where will you store it? And that can be reutilized for flushing. Okay, it can be reutilized for gardening and so many other things. Huh? So that is how the AC can impact other systems. So please be aware of these things when you plan your AC systems. Even if it's a small institutional, you still need to give me the drain point, you still need to give me the ventilation points, otherwise your AC will not function. And this is the slide which is going to show you the connectivity at all three levels. Okay. More or less the same, but little different. So again, the space to be cooled, वहां से आपका ये duct दिखाया गया है. Okay, so this is the duct that is going all the way to the AHU. And this is the return, the supply duct. The orange one is called as the return duct. So the blue one is called as the chilled air ducts from the AHU. You can see this arrow, बहुत पतला है, sorry, but you can see this arrow. It is showing the direction from the AHU to the space. And here you can see this blue arrow that is showing the direction of the air from the space to be cooled. That means it is heated air. That's why the orange color. Okay. And then it's going to the AHU. अब AHU में क्या होता है आप देखिए. Okay. So AHU में you have a fan, huge centrifugal fan, again a very large kind of a fan, because guys, please imagine that your entire corporate office is about 600 to 700 to 1,000 square meters. Okay, that means it's a big chunk of space, and you have one HU, and then one HU is supposed to take out these ducts, just like what you did in mechanical ventilation. Same configuration happens here. Okay, but in a more smarter and a more tighter manner. Because in mechanical ventilation, I am not really concerned about the comfort levels of the people, because there are no people. It's only cars there. Okay. While here, I am totally concerned about, because that's the whole idea of investing so much. How do I deliver correct temperature, correct humidity, correct cleaning, okay, all that, and the movement in a perfect manner so that everybody gets the required air. And that's how you will need to transfer this air all the way long, say around 25, 30, 40 meters. Can that happen via small fan? Impossible. You will need to go for a centrifugal fan to push the air so much. Okay, so one fan is already there in the basement. If this was say a ducting system, but if I'm saying AHU, AHU means definitely chilled water system. Definitely chilled water system. The moment I say chilled water system, यानी वो पानी को ऊपर भेजता है, chilled, which is done at the basement level. So now imagine this air is coming and the fan is sucking it, okay? At the same time, so you know now how the fan functions. At one end it sucks and the other end throws. So that's how it happens. So this is connected actually, ये पीछे जाना चाहिए, okay? Then the second part is the coil. Now this coil, okay, and then finally you have filter and you have humidity control. How do you control humidity? Say you are in Bombay and we have some 90-degree 90% humidity with this kind of weather outside, and when we have such highly saturated humidity, what do? You will introduce some dehumidifier, right? You have these amazing salts that are there, or maybe a heat kind of a thing which will evaporate the whatever. Okay, so basically you are taking the humidity out of the air, then it gets filtered. Now filter, we will do it later on, there are lots of filters available, okay, and then the air passes out and goes into the, and then it goes into the space thing. So when this the air comes here, it goes through all these things, okay, वो coil से pass होता है, वो humidifier से pass होता है, filter से pass होता है, and then finally it goes here. ठीक है? Now, what is the coil? Okay, fan, when I say the AHU requires ventilation, that's because I require 25% of air is added to it, okay, fresh air. Now this is required according to the ASHRAE. You know what is an ASHRAE, right? It's a body which deals with engineering of ventilation and lighting and everything. So that body has said that if you circulate the same used air again and again, you know, it doesn't have freshness. And to induce that freshness, I need to add a freshness in terms of 25% of external air is added. So what happens is the fan का जो पीछे का part रहता है has a duct which is diverted. One comes from the room and one comes from the window. So that is how, so the dirty air, or I would say warm air, or maybe mingled with somebody smoking there, all that particles will come here, okay. Also along with it, this air will come in. दोनों को ये chilled air से pass होता है and finally वो filter होके आगे जाता है. Now in many diagrams you will see that पहले filter रखते हैं, वो भी चलता है. Basically it all happens in a duct. तो फैन में से फिल्टर होता है, फिल्टर में से कॉइल में जाता है, कॉइल से ह्यूमिडिटी में कंट्रोल जाता है, एंड देन इट गोज आउट वेयर इन द रूम. ठीक है. नाउ लेट्स लुक दी व्हाट इज द सेकंड स्टेप. Okay, now this is the whole configuration is your AHU. This is what happens in the AHU. What happened? Why is this not going ahead? Okay. And now this was the coil. Now what is the coil made up of? Coil is made up of chilled water. Chilled water kahan se aata hai? AC plant room. Okay. So same thing happens. Okay. Let me go this. Okay. See what happens. So this is my evaporator where it is shown. It's blue in color. That means yahan pe chilling hota hai. Okay. So from here, what happens is, because this chilled water has happened, you remember the physics behind this, huh? Now this refrigerant has turned into gas. Now when something turns into gas, it needs heat. Na evaporation के लिए आपको heat चाहिए. If I'm having water and I'm boiling it, तभी वो जाके vapor होता है, right? Now this liquid refrigerant, when it is coming here, it takes the heat from the water. This is blue thing is the water. Okay. In turn क्या करता है water? अपना heat देके वो chill हो जाता है. Okay, and that chill water is brought here, and then it is circulated and it come back and again it goes up and it comes back. तो ये cycle अपने मजे से अपने whimsical manner में चल रहा है. Fan अपना cycle चला रहा है, ये अपना cycle चला रहा है. So it's basically all cycles are happening simultaneously. It doesn't के हाँ condenser हो रहा है तो evaporator शांत है. No way, it doesn't work. Okay, and that's where your BMS also comes into the picture. So BMS will be the one which will control this. So suppose the requirement of my AC is stopped, office बंद हो गया, ठीक है, शाम का 6 बज गया, people locked up and went out, and they forgot to switch off the AHU, but somebody comes and they switch off the AHU. The moment somebody switch off the AHU and this stops, automatically condenser stops. Okay, that's how the things are planned. And this is how it will work, okay, because nobody will, okay, 6 o'clock, so you go to the basement, you shut off the condenser ka pump, aisa kuch hota nahi, okay, everything is automated. So this is what happens. I hope up till now it is clear. Okay. Then what happens is, okay, so this is evaporator or chiller where the chilling happens. Okay, this is the compressor, this is the expansion, which we did all of this last time, which I again explained to you. Okay, condenser, and this is your AC plant room or the chiller room. Okay, and then again, now यहाँ पे chilling हो गया, now यहाँ पे heating हो गया. I have to take this heat out. So I'm taking this heat out. The hot water is again using the orange color. Okay, so the hot water to CT is cooling tower. Okay, cold water from CT. So this is my cooling tower, and from CT it comes here, it cools, it goes back again. So that's how this cycle simultaneously happens. Okay. Okay, now this, as I said, बहुत सारा spraying होता है ना, and I'm losing water. So to compensate that losing water and this to keep this guy cool, okay, I need this flushing water to be supplying to the, and this is definitely alternative source of water because no BMC or corporation or council will supply water for AC. उतना ताकत ही नहीं है उनमें, okay, they don't have the strength. So they will definitely, you will definitely have to go for alternative source of water, which can come from grey water recycling, which can come from, you can have tankers coming, okay, and supplying water to you in whatever form. It has to be alternative. Okay? Now, where and what happens? This happens at every floor level. HU, cooling, movement of cool air to hot air, okay, happens at the HU level. That is at the floor level. AC plant room कहाँ पे है आपका? Basement or the ground level where refrigerant cycle is happening, and then final cycle is your terrace or balcony level where your cooling tower is happening. So this is how the three cycles are connected, and finally you get the cooling of your space. Okay. Now the second thing that that was mentioned in the first slide was the factors on which you will decide which systems to be adopted. So that means what are the factors to be considered for cooling of space? It definitely depends on number of people and the uses of space. All services generally we know are banked around people, okay, are all floating around people. So you have floating population and you have fixed population, yani ki permanent population. And definitely the third thing that affects the cooling is your climate. यूज ऑफ स्पेस क्या होता है? एक्टिविटी बेस्ड होता है और टाइम बेस्ड होता है. ओके, नाउ व्हेन आई से टाइम बेस्ड एंड व्हेन आई से एक्टिविटी बेस्ड, एक्टिविटी में आता है आपका सेडेंटरी लाइफस्टाइल. All these things can come into sedentary offices, classrooms, hotels, okay, where people are just staying, okay, or the things are working, kitchens are functioning, and everything requires banquets are being there, people are sedentary, sitting at one place and eating. Homes, hospitals, patients are lying there. Factories, people are working there. Clubhouse, are all activity which requires 24/7, depending on the shift. Active में क्या है आपका? Where you have active sports area, gym, sports, club area, clubhouse and club area. In the clubhouse you have restaurants, you have nice libraries, you have cultural activity rooms where people will just gather, sit, talk, have conferences. While the other side of the club area is where you have all these other sports facilities, swimming pool, gym, gymnastics, okay, and whatever the club offers you. Okay. Then factories, again, depends what kind of factory it is. In some factories, you have they had shown one very nice documentary on Ferrari, how Ferraris are done. Now Ferrari has some part which requires people to take saman from one place to the other. I think it's available on BBC, I don't remember actually, or National Geographic, where they show all these manufacturing things. Okay. They have one documentary on IKEA also, again a very interesting documentary, when you should see it. So there you can see that there was a lot of movement of material as well as people. So it's basically active, and that's where you require higher kind of air conditioning. Okay, and gaming, yeah, gaming, people are very, kind of active kind of. And then time, you have continuous like offices, continuous like 9 hours, 8 hours, and then you have intermittent. So let's say continuous में of course hotels are there, hospitals continuously रहेगा, रात को भी लोग वहीं पे रहेंगे ना, they will not go home. Schools, and factories. Okay, so these are continuous shift hours. So at least 9-hour shifts are there, 8-hour shifts are there. While intermittents can all be this. Auditoriums, on and off. 3 hour का show है, फिर खाली है. 2 घंटे का show है, फिर खाली है. Conference rooms, if they are occupied, fine. Not occupied, fine. Clubhouse also not necessarily there. It depends. Clubhouse is not like a restaurant. A clubhouse is members will choose to go when they want to go and when they have time. So it's not necessarily that they are full all the time. So sometimes they are intermittently working. Morning times you will see that they are absolutely empty. Evening they are full. Library same thing. Okay. Evening times nobody uses. Afternoon times probably. Gyms same. You have peak times. You have non-peak times, and you have many other functions which I have not written down here. Okay, these are just few things that came quickly to my mind. Okay, and that's how you will divide your AC. But also remember, many building has multiple use spaces. So system use should be sustainable based on function and time. Systems are chosen. When I say multiple use space, matlab, can you guys give me some example? Otherwise, I'll give you one example. Ouch. Anyone think of anything? No one? Imagination, seen something, observed something. Okay, so in a corporate building, office building, today's corporate is far more humanitarian than previous ones. Okay, so they give all kind of facilities to their employees. So they have gym, they have libraries, they have creche for the people working there, so they can keep their kids and work up there. So ये सारी facilities देते हैं. Okay, now of course with the conditions. Okay, since it's not something that they are making revenue on, it's a facility for the employee. No outsiders are allowed. Now, if that kind of a space is designed in a corporate office, obviously you will not have gym working during the working time. Huh? So what they offer is the morning time will be the gym time. So say the corporate office starts at 10, okay, or 9, say. The gym will be open from 6 to or 7 to 9 or something, just like that. Okay. So people coming, and or also corporate offers you little leeway time. So they will say, okay, till 11 you can have a flexi time, but 11 o'clock you have to be, no matter what, you have to be in the office. Now if such kind of policies and rules happen, and this happens in most of the corporate world, then what happens is people opt to go to the gym in the morning, have shower there, they get their own clothes there, and then they go to the office. Okay, and then library is on. Now 11 o'clock gym shuts and library begins. Okay, now if suppose I'm using a package unit system, I can use the package unit sensitively and sustainably by shifting the same package unit to the library when library starts. So I don't have to invest for library as well as for gym. Same system can be used for both of these. So that's how you can have this, shift or multiple use of spaces, or you can say multiple uses of air conditioning, not spaces. But yeah, so this is how the systems can be managed. Systems could be, what do you say? Systems could be alternatively used to get me the best possible combination and save my money. Right now, coming to the which systems I will use for sedentary, since I require all the time, obviously I'll go for something that is heavy duty, a system where non-stop conditioning is required. That means a centralized. Okay, but again, whether should it be centralized, whether it should be packaged, Consa centralized will depend on the area. Okay, if it's a small kind of an office, obviously my consideration will not be centralized. So remember all these things. Okay, these are some of the factors on which you will plan your air conditioning systems. Gym system where heavy air conditioning is required continuously. Imagine a gym functioning from morning 6 a.m. to night 10 a.m. You will need to go for a, and it's a large gym, kind of a, like a huge kind of a area. Obviously you will have to go for a package unit and with a ducting system. Okay, the split system probably is not a very good idea there. So these are some of the factors and systems that you will have to opt for. Again, continuous, centralized, depending on the area, or intermittent में the same thing that I explained you here. I can shift library to conference, library to gym, or gym to Audi, whatever. So again, preferably system which can be on and off. Any questions so far, guys? I am not looking at the chat, so please, if you are chatting, I don't know, I'm not looking at it. So anybody has any question, please put on your mic and speak up. Otherwise, I'll go ahead. Okay, I'll go ahead. Okay, so and then the next set of questions. Oh, great.
In the chat. There are no questions.
Okay. Right. Thanks, Swati. What kinds of systems are available is one question that then you will ask. Na? Where does one use which system? कौन सी system कहाँ पे use करे? Is it dependent on just people or area or activity or all three? It is something that you will need to sit with your consultant and talk about it. And if you are planning till at least final year, where you are not going to use any consultant and use your own brains, okay? You will need to think about all this, okay? Remember this when you are planning your air conditioning. Which system is more sustainable, okay? And that we will study aage jaake, what happens in what system. Can these systems be added later on in the process of design, or should they be a part of the design brief? Is something very logical, right? I mean, this should be a question best left unsaid, because you know what to do. Can two systems work together to achieve more flexibility, cost, and energy savings? Again, a very question that needs to be concerned and asked by you guys, because the moment you say two systems, that means two spaces, okay? That means two different spaces, probably at two different levels. That means probably two different maintenance teams, and that means probably two sets of another set of services that will go auxiliary with it. So yes, it's something that will interpret, I mean, it will finally manifest in your spatial planning. That's definitely what you guys are appointed for, right? So yes, ये definitely आपको सोचना है. What will be the repercussion, suppose, if I don't think it as a part of the design brief? What if I don't think of the flexibility, cost, and energy saving? What if I don't think of what system to go where? अगर ये हम अभी नहीं सोचेंगे, the repercussions are going to be not paid by you. Let me be very frank. As an architect, आपने तो plan करके छूट जाना है, okay? The contractor भी छूट जाएगा, but the owner, okay, जिंदगी भर आपको curse करेगा, because you did not pay attention to this, and he is left, okay, with a blunder in his hand made by you and your team, and he has to pay the repercussion in forms of money year after year, year after year. So yes, and the repercussions, by the way, are tremendous, okay? And it is not in terms of thousands. When I'm talking about chilled AC, chilled water systems, the repercussion comes in terms of lakhs of rupees, okay? Really lakhs of rupees. Our electricity bill, before we went for LEDs and all that, was around 1.5 lakh rupees every month. I'm talking about KRV. So with those systems, AC systems, with the fans on, with the lights on, students leaving the fans and lights on, if they go for the lecture, studio ki sari lights on hai, okay? But the bill was paid by the college. The bill was around 1.8, 1.5, 1.2, okay, till intervention in terms of LED happened, okay, in terms of computer shutting happened, okay, and many other things. So these are the repercussions. Monetary repercussions, year after year, months after month. How much area will be required to house these systems? And I'll show you the pictures to understand what will be the areas by these machines that is required, okay? Which I also showed you last time. They were pretty huge, okay? Are they FSI free because they are services? Yes, they are FSI free. They're generally kept in a basement. How can we design buildings? And this is one question I always ask before we get a project, and that is it possible for me not to use air conditioning at all? I am teaching you air conditioning, but I am not a big fan of air conditioning, okay? It is one of the most unsustainable systems, okay, where people more and more are banking on it and creating hustles in the world. So try to achieve non-AC building as much as possible, and definitely guys you will get applauded, if not by anyone else then by your kids आगे जाके. Okay, so different systems of ventilation is what is now we are entering into the zone of all the different, so your unit systems, your central system, your VRV systems, all that. So ventilation kya hota hai? Okay, it's divided into three. You have natural ventilation, which you did in first year, second year, third year, and I will say continue doing this throughout your life. Okay, this is something that I love the most. The second one is forced, where we studied mechanical ventilation. Okay, and finally we have something called as a conditioned ventilation, air conditioning. Okay, when I say forced, it's mechanical ventilation, and yahan pe you have cooling as well as heating. In mechanical you have positive and negative. Okay, now when I say negative ventilation, it means I am taking the air away from the building and creating a negative pressure there. Okay, that's negative ventilation. When I say positive, I am throwing air into the space and creating positive pressure there, making the air more positive, making it more fresh. That is called positive ventilation. And that is why your fire systems, especially where people are supposed to travel, say in a corridor or in a fire escape staircase, I will be using positive ventilation where I'm bringing a lot of air from outside, and via ducts and fan, I'm pushing it into the lobbies, pushing it into the fire staircases, so that the smoke will not be able to enter that, because air is gushing out of the staircase rather than smoke coming in. Okay, so that is what positive ventilation is. And when you have a very large area which you have to do the mechanical ventilation, one of the system will not work. You will have to opt for both systems, because here you are talking about the depth of the building, length of the building, and if the area is very large, one system alone probably is not feasible unless you have natural ventilation very nicely incorporated within that area. That's why in the basement, since the basement is within the ground and you have that teeny weeny tiny kind of windows happening there, वो भी बंद position में, and you don't know कि उसके सामने बड़ा कार खड़ा है because the parking is happening right outside, then so there is no chance of having any natural ventilation, and the whole area is doomed. Okay, if I depend on it, that's why I go for mechanical. But then if I say no 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 no, I am only going to do negative, window से अपने आप हवा आएगा, कैसे आएगा भैया, कोई जगह ही नहीं है बाहर. So you will have to then really put your brains to understand the context around your building and then apply whichever method you want to do. So these are the two methods by which you will do your mechanical ventilation. And then finally you do the cooling. Cooling mein again, you have centralized system and you have unit system. Now in centralized system, we are first going to do the centralized system, okay? And then we will go for the unit system. Now centralized system are four, and these are there. You have chill water system, you have direct expansion system, you have VRF system, and you have air displacement system. Actually, air displacement system nahi hai, okay? But it's just a method, and it's something which is very popular. So I've added it as a system, but actually it's a ducting system, okay? So, but understand this, okay? So now, what is a chill water system? I already showed you the diagram, AHU wala. Chill water में आपका AHU is a very important part, okay, element, system part, okay. Without AHU, system will not work, because chill water को आपको ऊपर भी coil में घुमाना है, ठीक है, and that coil is again the same what I showed you last time when I showed you the parts and components of the machines placed in the plant room, okay, where I showed you that copper coil wala box, okay, which was a chiller. But AHU में भी जो chiller होता है वो same होता है, okay, same configuration, because the agenda is the same. I need to push the chilled water in such a manner कि maximum surface area मुझे मिले, जिसके ऊपर से when I put a fan, I get a lot of cool air. That's the idea. That's why I use lot of छोटे-छोटे copper cubes, okay. So AC plant room is required in a chilled water system. I require AHU at each floor. I require cooling tower or a fan room, okay, cutouts in slabs for chilled water pipes to run to and fro. Now, chilled water pipe is going to each and every level of the building, okay, चाहे वो 16 माले का हो या 26 माले का हो, doesn't matter. It will have to you will have to cut a slab, allow the pipes to come up and run them every floor up, okay, unless as the one of the question that was there, you are saying the top 3 floors are probably being used for package unit, maybe, okay, then I don't need to make a cutout there. But so why am I saying this? Because you guys have already done your working drawing project, right, in 3rd year. So now you know what is an importance of showing a duct, okay, because वहाँ पे आपको cutout दिखाना है, all that thing will matter. So that's why. And if you are doing this, you will have to do the working drawing set for each and every drawing, okay, or you will have to make notes that this cutout is there for so and so floor. ऐसा सब करके you will have to basically tell the contractor. And then finally you have high maintenance at the basement at the AHU level. So that is something that will go along with your chill water system. What happens in a direct expansion system is I again require AC plant room. Okay? I again require cooling tower but I don't require HU. Now what happens here, please understand. Try to remember the second diagram that I showed you today, okay, where I'm showing you what happens at the floor level, what happens at the basement and what happens at the cooling tower level. Okay? Wo diagram mein, please go back and see that blue box and the yellow box that was condenser and the evaporator. Okay? Now imagine this evaporator box that is placed in the AC plant room. Now chilled water में हम क्या करते हैं, evaporator को हम पानी में रखते हैं. So the water is the one which is giving up its heat for the evaporator, for the gas to refrigerant to turn into gas, okay, and फिर that chilled water is taken up. Versus direct expansion system, where what I do is I put a big drum of air, okay, it's just chilled air. Now mind you guys, chilled air is not like your air in the AHU. कोई 25% extra इसमें नहीं आता है. This is completely hermetically sealed kind of no, it can't be sealed, okay. What happens is you have this air, okay, and you are blowing a fan on it, okay. So what happens is this chilled air is then taken to via ducts to the area. So sorry, my mistake, it's not hermetically sealed, it's not sealed at all, okay, but somewhere you will have to supply the air. So what happens is then that air from the room is coming back, the return air is brought back to the basement, okay, and it doesn't have the AHU, it comes back to the basement, same dabba, same chiller, okay, where again it gets chilled, and then with the help of the fan it goes back again. Now just understand this, okay, is it easy for me to transfer a huge amount of air from one place to the other, or is it very easy for me to transfer water from one place to the other? Water can be taken up via very small pipes, है ना, because anyway ऊपर जाके उसको छोटे छोटे coils में जाना है. So it will be very easy for me to take a 2-inch का pipe, even if I give a lot of thermal insulation, because I don't want to lose that chilling, okay, I want to conserve that and save energy. I will have at least 6-inch, okay, it's like really thick. That's why the size of my chilled water pipes are big. Pipes are very small, 2 to 3 inch. Inch बोलेगा तो 75 mm, maybe 50 mm, and that will take it up. Of course, I am not the right person to say what is the size of the pipe, because it depends. If your building is just 10 floors, 2 inches good enough. But if your building is say 50 floors, then that 2 inches probably not enough. You will have to go for 6-inch pipe. So again, it depends on the use, it depends on the facility, it depends on the density of the building, okay. Now coming back to this, so it's very easy for me to take this water up via pumps, like a normal water supply we do via pumps, okay, and then supply to the AHU or versus something that I would take a huge amount of air via those huge ducts to that area, say, okay. That's where, guys, you can say that direct expansion system is used for small facility. Okay, say I have to do a small auditorium, खाली auditorium करना है, and you know auditorium requires to be on and off. It will not run throughout the day, or it will not run every day. So it depends when whoever plans it, or क्या बोलते हैं उसको book करते हैं, based on that it will be work, ठीक है ना? So a direct expansion system works well for a smaller establishment, okay, while chill water can work for a very large establishment. The tonnage for a direct expansion can be 40 to 50 and that's it. वो ज्यादा नहीं करेगा, कर सकता है, it's not that it cannot do, because AC plant room cannot have the, it can go high, but the problem is taking the air and then taking it to that area, so that is a problem. While chill water, you can have 400 ton, 500 tonnage, 600 tonnage, chahiye utna, and that's how you will do your this thing. Now again, just as a precaution, and since we have already done high rise, if you have to take very long pipe, say Burj Khalifa, it's not possible ना, हम पानी नहीं लेके जाते हैं तो chill water कैसे लेके जाएंगे, है कि नहीं? So in that case, definitely your building is again zoned. So what happens at the basement, at the HU, at the terrace level will happen at every mechanical floor. So every mechanical floor will then have to think of a way to put the cooling tower in a way where it is exposed to the thing, So yes, that is how your high-rise buildings will function, okay? So mechanical floor will again have repetition of all the systems, because this system is then possible only for, say, first 30 floors. The second system, another 30 floors, or maybe 60 floors, whatever, okay? So that's how you will divide it. VRF system, it's a unit system, okay? But unit system with a difference in the sense, a unit system ka capacity hota hai 2 ton, 1.5 ton, 1 ton, okay? While VRF can have at least 50 to 100 ton ka aram se you can have a VRF system, okay? That's why it is, though it is a unit system, it comes under centralized system, okay? So that is the difference between the main central system and the VRF system. Plus VRF system mein I can go on adding units as my requirement of the air conditioning increases. So that is another advantage of VRF. VRF also gives me the control of the flow of AC into certain area. Centralized AC में आप नहीं कर सकते हैं, है ना? आमिर खान का क्वेश्चन था, जरा पंखा इधर घुमा, in that famous कौन सा मूवी, रंगीला, right? Because it was centralized. वो waiter भी बोलता है, sir, centralized AC है. You cannot control AC in a centralized system, okay? But with the new technologies coming, there are now, so we do zoning and all that. We'll do that later on. But I'm just saying, it is difficult, okay? Even if you zone a building, उस zonal में एक बार zone हो जाता है, within that zone you cannot control. I can control the zones. I can say one zone is at 10 degrees, the other zone is at 18 degrees, okay? One zone is at 22 degree because यहाँ पे लोगों को कम चाहिए. Zone wise I can do the control, but within the zone if somebody says बाबा मुझे ठंडी लग रही है थोड़ा कम करो या ज़्यादा बढ़ाओ, नहीं हो सकता, sorry. So that is a limitation in a chill water and a direct expansion. BRF, you are in the same room and you can control it. It has that part. So that is another factor of sustainability that is added on, okay? Anyway, we'll do that later on, aram se. It's a unit system. Terrace can be used, so that's where I said a VRF system or VRV system can be placed easily on a terrace since it comes in units. Again, it has condenser, it has a evaporator, sab kuch same hai because that is the basic cycle of air conditioning. So definitely you will need a fan room or a cooling tower, okay? And definitely highly sustainable, as I just explained. What is air displacement system? Again, very highly sustainable. Normal methods of cooling are applied. Same, you will have the same basement requirement. You will have probably the same AHU, but the way you do your ducting, okay, but the ducting method is very different. So though it is only a ducting possibility, it is always more or less, okay, termed under central system, okay, because ducting आप एक छोटे से area के लिए कभी नहीं करोगे, है ना? Whenever you plan ducting, you plan for a larger area. छोटा area होगा तो we go for a unit area, a unit AC. Why will then I think of ducting? है ना? That would be pointless. So that is why air displacement system generally, though it is a ducting method, is placed under central system. Do not get confused about this. Any questions so far, so forth? सबको सब कुछ समझ में आ रहा है? Or should I go slow? Should I go fast? Should I repeat something? Somebody speak up. Okay, I go ahead. I really love your class.
Nina, question.
Yes.
So the case study that we're doing for the high-rise building, it was KM Tower. Uh, for the MEP systems, we had read that there was a centralized chilled water pipes system that was running. But the building is completely residential. So then, how do you control the amount?
Good question. Okay, very good question. I was talking about zoning, na? So zoning mein there is something called as FCU. Okay, fan coil unit. Same question I will ask you. Say you
Yeah.
are going in a and staying in a 5-star hotel. ठीक है? अब आप boys का gang जा रहा है, girls का gang जा रहा है. Okay, that you generally do in a study trip, right? And then each one of you have rooms. Now, not necessarily each one of you will use AC, right? Like person like me will never use AC. Okay, I generally don't use AC. Now, I will not start the AC. But बगल में जो है, okay, वो मेरे तो बहुत use कर रहा है AC. वो जो भी कोई है, right? So how can I shut off the AC but the AC is there on? It's like adjacent rooms, yet I am able to have the control, but it is a centralized AC. Okay, so that is the difference in the previous technology and today's technology, and that's where I said, okay, within a zone, it is not possible for me to control unless I go for FCU. FCU will give you a control because you will have separate unit for each room. और वो क्या है? We'll do that later on. But I'll answer your question. But I hope I answered your question. So same thing will happen in a in a residential. Every residential will get a supply of the refrigerator or the cool water. Sorry, not the cool water, chilled water from the basement. Sorry, guys. Sorry. But once the water comes into the residential, okay, there is a separate unit placed there, okay, which is nothing but a coil. That's the best part. Okay, it will just have a coil and a fan. That's why it is known as a fan and a coil unit. जो नाम है वो काम है. Services का मुझे ये सबसे अच्छा लगता है. What is there in a name? काम भी वही करता है. So the whole thing is known as a fan coil unit. A unit which has only a fan and a coil. पानी देता है कौन? Basement. हाँ, तुम्हारा AC plant room. Okay, so we'll cover that when we do that. Did I answer your question?
Yeah. Thank you.
Okay, so we studied the centralized unit, charge system tha, chill water, expansion. Then you have VRV, and then you have your displacement displacement system. Now we have different unit system. I am sorry, I think I have made a mistake here. पता नहीं, आप just check कर लो अपने उसमें approximately 28 cubic meter है कि कम है? मेरे ख्याल से कम होना चाहिए. I'm not very sure. I made a mistake here. I think so. But so you avoid looking at approximately 28 cubic meter. Just focus on 1 ton is equal to 1000 cubic feet. तो कैसे होता है? I'll tell you. In the HVAC field, a ton or a tonnage refers to the cooling capacity of an air conditioner. That's why जब हम खरीदने जाते हैं हम बोलते हैं ना हमको 1.5 का टन का AC चाहिए, or we want 5 ton का AC, or we want 10 ton का AC. Okay, so the ton is what is the cooling capacity of that unit. Tonnage is measured in BTU, British thermal units. Okay, a ton is used in HVAC field is a term that describes, it's very simple, how much heat the AC unit can remove from a home in 1 hour. And do you know how this, and it's a very interesting history for this. So in I don't know which place, that I don't remember, but I just remember the incident where a boat, okay, and this was a winter time, and it was frozen, okay, and the whole machinery was frozen with the ice because there was a rain a previous night with so much of cold, and the whole thing had done. Okay, and somebody said, "Abhi isme, how do you run the boat? Okay, it's exposed to the element, and how do you do that?" अब exactly वो boat था वो मुझे याद नहीं, but it's something like that. And then they said, "Okay, we'll melt the ice, okay, and we can start the machine." And that's where they started melting the ice, and they realized that, and when the water was collected and measured, okay, some bright guy got an idea, why not we measure the water and then see how much heat went into cooling, I mean melting that. So the same reverse application was done. Yeah, how much heat AC unit can remove from 1 hour. So that was how the tonnage came into the picture. Okay, so ton क्यों है? Because what ton of ice था. That was the idea. Okay, so that is always this question. How do you measure air or cooling in a ton? Because ton is something you measure a material, ना? हम बोलते हैं ना 1 ton of wheat, 1 ton of rice, 1 ton. Air कहाँ से आया? It's because that 1 ton was that ice, okay, which needed to be melted, and that heat जो हुआ, वो that was how the conversion of tonnage happened. So that's how the ton is used. Okay. Now, if suppose you have a small area, okay, तुम्हारा bedroom पकड़ो आप 10 feet का है, यानी 3.3 या 3.28. You have 10 feet by 10 feet का आपका छोटा सा square kind of a bedroom you have, okay, with a height of a 10 feet. That means 10 into 10 into 10, okay, that is 1,000 cubic feet. Now this is a thumb rule, and we architects love thumb rule, okay. 1,000 cubic feet is equivalent to 1 ton. And that's why mostly our bedrooms we will have 1 ton. We won't go for 1.5 unless your bedroom is on a larger kind of an area, okay, where you have 14 meters by 16 meters ka, sorry, you have like 4 meter by 5 meter, a big kind of a bedroom, then you go for 1.5. That's how it is measured. Okay. Now, having said that, unit systems, again, you have these. So you have package system, you have split system, and you have window system. Okay. Window system आज इतना नहीं मिलता है. Okay. First, let me put all this so that you get a complete idea. Okay. So, oh, sorry. Okay. So we go back here. So let's study window unit first. Window unit is what you get in a market. आप बाजार में जाओ, एक बक्सा घर पे लेके आओ, एक कारपेंटर को बुलाओ, विंडो में फिट करो, and your AC is on. ठीक है? You put on a switch and your AC is on. That means जो things that I told you what happens in the basement, all that compression cycle is all fitted into that box. उसी में आपका कंडेंसर है, उसी में आपका इवोपरेटर है, उसी में आपका फैन है. ओके, बिकॉज you need to push the air out, right? Cool air नहीं तो बाहर कैसे आएगा? So you need to push the cool air out. So there is a fan right in front of the behind your evaporator, which blows over the evaporator, which carries cool or a chilled refrigerant, and that's how you get cool air. But reverse भी तो होता है ना, वो कंडेंसर जो है आपका वो भी हीट हो रहा है, उसको भी फैन चाहिए. ओके, सो द फैन एक्चुअली वर्क्स बोथ वे. एक तरफ से वो हीट निकलता है, एक तरफ से आपको चिल्ड एयर अंदर देता है. सो दिस इज हाउ यू विल हैव, और यू प्रोबेबली विल हैव 2 फैंस इनसाइड. So that's what your air conditioning window unit is. Now, because you have compression inside, because you have fan inside, there is always this humming sound that comes from the window unit, which is very irritating. Okay, and imagine sitting in a small area and you are continuously listening to that kind of a humming sound coming. It's not very productive. Okay. So it is one of the bygone eras now. You don't get Windows unit nowadays unless you go to some second tier, third tier cities. But mostly in Mumbai, if you go and ask for a window unit, they will look at you with doubt. Then you have a split unit. Split unit, so I'm sure you have it at your own homes. अगर घर पे नहीं है तो आप कॉलेज में आए हुए हो. What you see in a comp lab, what you see in a अपना AV room is your split AC. So split, as the name suggests, is split. What is split? All the noise making, all the heat making, okay, because I don't want heat inside my room, na, mujhe to cool chahiye. All the heat making and the noise making element I separate and I put it outside. Okay, I split the system. So what the system was happening in the basement? Basement में क्या हो रहा था? You had your condensers, you have your evaporator, you have your compressor, you have your expansion. ठीक है ना? Both of them are in a looped in such a way that they are diametrically opposite. Condenser गर्म होता है, evaporator ठंडा होता है. Compressor pressure देता है, evaporator pressure release करता है. So they are diametrically opposite and placed opposite to each other. That's how you will remember the cycle very easily. This is how I remember. So this is how, so then what you have to do in a split unit, take out the condenser and the compressor because one is heat producing, one is sound producing, and keep them out. Okay. What you need inside the room is evaporator with a small, and today we get fans which are on a silent kind of a thing. Okay. So you put a fan there, and that's how you will start getting your what do you call cool air within there without the noise and without the humming sound that comes from the compressor. So this is how the split works. What are the window ka capacity kya hai? Generally 1 to 1.5, and that's it. You do not get more tonnage. Why? Because window unit kitna bada hoega? If the window unit is too big, your whole window will be occupied by the unit. Then where will be the light? Where will be the natural ventilation? You can't just survive on complete AC, right? So that's the reason why the limitation of the window unit is there. More the tonnage, more the capacity, more the size of the unit, and lesser the size of the window. Problem. So I cannot have more than 1 ton of window unit. स्प्लिट में आप कर सकते हो क्योंकि यू आर स्प्लिटिंग इट है ना. तो आप कंप्रेसर थोड़ा हायर क्वालिटी का लीजिए, हाँ, कंडेंसर को हीट बाहर रखा दीजिए और इवोपरेटर अपना कॉइल है और फैन है, काम कर रहा है. So you can have varied kind of a tonnage here. You can have 1 ton, okay, 1.5 ton, 2, 5. ये 5.5 ton wrong है. It should be 1.5 ton. So you get 1, 1.5, 2, 3 tons as well as 5 tons. Okay. So various kinds of tonnage are possible in a split unit. Package unit is actually a wonderful system because small system hai par bada kaam karti hai. Okay. So package unit is a very big brother of window. Window तुम्हारा छोटा है, तो package unit big brother है. In the sense, everything what was happening in the window unit is happening in the package unit. That's why the package. It comes as a package. Okay. It comes as a big box like a cupboard which you can bring from outside and put it in a room and the system starts. Simple. Okay. System starts. Difference kahan pe hai? Because it is a larger system, because it has a larger tonnage available, and you can see some of the tonnage is available till 20 ton. A 20 ton is what our auditorium can be done with. Our whole auditorium, the tonnage is around 10 to 15 ton, and that's how it can be easily cooled by one package unit. Okay. But when I'm saying a package unit, again, आपको condenser भी वहीं पे है, your evaporator is also there, and now you need to cool that condenser because I can't allow the heat to build up there. That means I need a fan there. But again, 20 ton ka hot air will be so tremendous. I cannot afford to. I mean, people do it. Let me tell you, there are people who are dumb enough and insensitive enough to do that. Okay, but ideally it should not be done. Okay, so what you should do then is take the क्या बोलते हैं, water cooled condenser. That means you will need a cooling tower. Even if it is 20 ton, छोटा सा पर चाहिए. Okay, you will still need a smaller level of cooling tower. ठीक है. So this is how it will be done. So some of the questions people ask me, I'm sure you guys will not ask me, but people have asked me this question is, what happens in Rajasthan when there is no water? Very good question. The question is then, who is saying that you need to use a potable water? Any kind of water will work. Okay. So the water that can be then derived from your own building in terms of grey water recycling, rainwater harvesting. Okay. All that water can be used for the cooling of condenser. So that is where a water cool system is possible in Rajasthan as well. Okay. Even though there is dearth of water. Because imagine करिए, already it is very hot outside, there is 40-degree temperature in Rajasthan. On top of it, you are pushing this 20 ton of hot air again into it. And very soon it's going to turn into 44 and 45. So that's what we don't want to do it. And that's where your choice of cooling condensers will be very important, and not only for the atmosphere, but for your structure as well. Because you will have to plan the load of the cooling tower and alternative method of water supply. So yes, you will have to have a makeshift tank. So yes, sir, matters at the architectural level as well. Any questions so far, so forth? Okay, I'll go ahead. So this was about the unit system. We have window, we have split, we have package. I hope I'm very clear about this. Okay. Package unit में क्या करना पड़ेगा आपको? Package unit में you will have to keep it in a room. Okay. And obviously when I'm talking about 20 ton, that means it's a kind of a big machine. And when I have a big machine, that means it requires big maintenance, and that means I need a very good access. Also, when I have a condenser sitting there, as well as that compressor, it's going to make noise. So I have to have acoustical treatment. I have to see to it that the placement of the package unit in such a way that it does not matter to me when I'm working there or trying to work there. Okay. Otherwise, that humming sound is going to affect my productivity. The third thing is drainage, because evaporator is going to condense and it's going to shed water. So you need to collect that water. Ideally, you should collect the water and reuse it. Again, push it back into the cooling tower cycle. So yes, you should have it collected and channel it properly. You can push it into the potable, non-potable source at the thing. So all that systems will have to be suggested by you, because you are the architect and you are the one who is actually designing the building for such things. तो अगर आपको ये पता नहीं होगा, and if you don't answer or question the consultants will take you for a ride. Okay, that's the reason why we study all this. Otherwise, what is the need for me to study so much of engineering? I don't. Okay, but as an architect, I need to not be taken for a ride by the consultants, and hence the need. So these are the things that one has to do for the package unit. Now, package unit, because the tonnage is very high, that means the area is going to be larger, and that means I will have to go for complete ducting system. ऐसे नहीं चलेगा कि आपने package unit window के जैसे लगा दिया और फिर वो चल रहा है. The people sitting near the package unit will start freezing. Okay, while people stay away from the package unit will have problem, which is exactly what we face in a AV room when you have your split ACs working. People sitting under the split AC are shivering, while people sitting in the middle of the AV room are feeling hot, because probably the louvers are not working well, or the fan needs some kind of maintenance, or whatever it may be. So we don't want that to. अगर वो 1 ton में ये हालत हो रहा है, imagine 5 ton. You will be frozen there. So we do ducting. And ducting is then taken, just like you do your mechanical ventilation, you will do the ducting for your AC as well. And you will take it into the room, and wahi tumhara diffusers, grills and everything, which I'll be showing you in the next lecture, not now. But just understand this. So ducting is required when you have the package unit. Okay, so this was about the different package unit. Okay. This is now we are coming back to the chill water and learning the process of exactly what happens in a chill water. Okay, so this was the diagram. Blue stands for evaporator, yellow stands for condenser, the orange or the beige color kind of stands for expansion, and the blue rectangle stands for the compression. Okay, so 1, 2, 3, 4. What is 1? Is a compressor. One is, sorry, your evaporator. 1 second. 1 second. Yeah. One is your evaporator coil, which we did it, but I'm just recapping it. Okay. I need to do this again and again as per some of the last year's comments, because they found it very confusing and not able to remember. I hope this helps you to remember. Evaporator coil, क्या होता है evaporator coil में? Low pressure, low temperature, refrigerant, gas होता है. ठीक है. Compressor में क्या होता है? compresses and turns refrigerant into high pressured, high temperature gas. तो यहाँ तक अभी तक आपका सिर्फ gas है. All the blue line you see till here is all gas. ठीक है? Now third में क्या होता है? Condenser. Condenser is turns high pressure temperature gas into liquid. Again, I'm repeating all this. Sorry, but yeah, that is required. ठीक है? 4 is expansion valve, releases the high pressure temperature and turns into low pressure gas. Even if you guys don't remember all this pressure business, na chalega. Just remember where is heating and where is cooling happening. Even if you remember this, you are set. Okay. Now, where is the heat taken for the refrigerant to convert into the gas? Yahan pe, okay. It is the latent heat of the water. Then that's where your chilled water system, where chilled water is the means to transfer heat. Okay. This is how it happens. Okay. Water gives up its heat, turns chill. This chilled water is taken to AHU, which we saw in the first diagram. Okay. And यहाँ पे we have done this. ठीक है. Or fans are used to cool condenser, and the hot air is released at the terrace level. Okay. That's how it happens. ठीक है. Direct expansion system. I want to show the difference. That's why I am doing this again. Sorry. So I'll quickly go. It's the same. Okay. This was very easy for me to do because I just had to copy the diagram here. But difference ये star है. ठीक है. The fan. Okay. Now this fan वहाँ पे क्या था? कुछ नहीं था. Okay. वहाँ पे water था. यहाँ पे क्या है? आपका fan है. So this dabba is now not filled with water. It is filled with air. Okay. And the coil kept in a container attached to the air is taken to the space and not the water. This is the main difference between the direct expansion and the chill water. Please understand this, guys, because this will be so obvious when you do your diagrams. And if suppose this question is asked in your exam, my suggestion is please draw the diagram. Okay, a good diagram with a colored pencil or pen is the sure shot way of passing without copying. Return air is brought from the space to plant room. Okay, so this is how a difference between your direct expansion and a chilled water is obvious. Okay, नाम भी बोलता है ना, एक बोलता है chilled water, आप water को chill करो और फिर लेके जाओ, दूसरा बोलता है expand करो, what? Air. Okay, so that's what you do it. I mean, you don't actually expand. I don't know why this direct expansion system came into the word. This is one word which I cannot relate to the function. You are not expanding the air. Sorry. Water surrounding the C coil, that means the condenser coil, which is taken to CT, which we have done and already done. Okay. Difference between difference between chilled water system and direct expansion system. Chill water is used for larger areas, which I already told you, because the tonnage can be higher. Okay, and it is very easy for me to transfer water from one place to the other. While direct expansion में क्या होता है? Used for a smaller area to be conditioned. Used when the continuous air conditioning is required. Remember the factors to be decided, factors on which the AC is decided, जिसमें आपका continuous requirement था. Okay, that is where I require chill water system. If the requirement is heavier and higher and more, I will go for chill water. When the intermittent cooling is required, छोटा amount में, छोटे time पे, then I'll go for direct expansion system. Air is passed over chilled water, which are chilled by refrigerant. So air किस पे pass हो रही है? Chilled water पे. Chilled water क्यों होता है? Because it is giving its heat to the refrigerant. While what happens in the direct expansion system, the air is passed over chilled refrigerant. Okay, you have the coil जिसमें आपका वो हो रहा है. Okay, over which you are passing the chilled air, which is chilled because it gave the heat to the refrigerant. It turned chill, and then the fan is taking it to the room. Usually water cooled condensers, these could be air or water cooled. Okay, if you ask me, all the air conditioning should be water cooled. Okay, because it is very easy for me. That way I am assuring that even my other systems are not related to the AC but related to water, I am recycling water. If I am not concerned about this, if I am saying चल ना fan लगा देते हैं, ठीक है, who cares? Then I will say who cares about rainwater harvesting also, and probably I will not even do anything about grey water also. But if I am concerned about the environment, and if I say, no, 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 I cannot give this much of heat to the atmosphere, I need to make somehow possible कि मैं इतना पानी कहीं से तो लेके आऊं without charging my client so much, then I will suggest him, Baba, please go for harvesting and also go for grey water. Okay, इसमें आपका landscape भी अच्छा आएगा because all that grey water can be very beautifully remodified and cleaned by phytoremediation, having lovely landscape, and then the water can be cleaned and pushed back into the system. So that way it's a win-win situation, okay? So an AHU is a necessity in a chill water. Direct expansion mein AHU is not generally required. Now why I'm using this word not generally required? Ideally मैंने बोला not required. Suppose, okay, just suppose you have a basement and you have an Audi. Now भगवान ना करे आपका Audi बहुत दूर आपने प्लान किया है, हो सकता है, चलो अभी अभी क्या करें. But suppose if that is a situation that your Audi is damn far away from your basement, okay, or basically the AC plant room. Now it is, you know how the refrigerant ना बड़ा ही volatile है, बहुत जल्दी mood बदलता है उसका, and the phase भी बदलता है. Now if you have this kind of a material which is very eager to change its phase, you need to be little bit more careful. So what you do is you introduce AHU. और AHU कैसे होता है, उसमें पानी नहीं जाता है, उसमें refrigerant ही जाता है. Okay, so you choose a refrigerant, first of all, which will be little less volatile, okay, which is able to travel long distance, okay, and then it goes to the AHU, and AHU में फिर आप fan लगाते हो and the same thing happens, okay. But ideally what you are saying is instead of taking an AHU is between your Audi and your basement, यानी कि the travel of the Audi, the refrigerant is lessened. That is the only requirement. Did you understand what I just said? Somebody please put on your mic and say yes or no. Did you get why I said this AHU business in direct expansion system? Guys, I'm asking you a question. Fine, then I'm closing the lecture. If you are not bothered to answer me,